Have you guys ever heard of a histogram before? All right. So, did you guys finish? Most of you guys were here on Friday. We talked about um, measures of center, describing graphs, dot plots, and stem plots. Okay, we're not going to talk too much about those because we use dot plots and stem plots for small data sets. But we're going to start to get to some larger data sets, meaning a large set of numbers. And in a little bit, I'll have you guys create one of these on the computer. I used to make you do them by hand. We used to use those calculators in the back, but not everybody has access to those calculators. So there's easy ways to do it in the computer. I'm sure all of you guys are computer savvy, can follow directions, and if I show you how to make one of these. Okay. Before we start, I'm just going to ask you guys a series of questions. Take a look at this histogram. Even if you don't know anything about histograms, okay, even if you don't know anything about histograms, can you tell me how many trees are between 250 and 300 centimeters tall? Tell me how many you think. How did you get that? Yeah, that bar that's between 250 and 300 is literally 50 trees high. It says there's a number of trees over here. It's 50, and then you have the 250 to 300 right there. It's This is what's called a histogram, where we're actually counting how many fall between a certain interval. In that case, the question that I just asked you guys, the interval is 250 to 300. Okay. There are a couple of things I want to point out here on the histogram before I show you the definitions. But what was I going to say? Oh, I can't annotate on this screen. I forgot. Um, where's my mouse? The width of each of these bars is how much? How much is each of these bars wide? They're 50. Okay, they're 50 centimeters, really. Okay, that's called the bin size of a histogram. The bin size of the histogram. What axis is this? That's the x-axis, and I hope you guys know that this is the y-axis. Okay, a little bit of algebra back for you. Oops. It's weird doing it this way. So here's a histogram, a graphical display that we use for large data sets. And like I said, in a little bit, I'll have you guys make your own. And it just shows you how many times something shows up in between a certain interval. And the bin size is just the width of each bar in that histogram. Okay, super easy to make these. I'm going to show you how you would make a histogram by hand. But you guys that aren't actually going to do that this year because they're going to do it all digitally. But this is what would look like if you made a histogram by hand. Imagine if you had all these birthday cards, and these are the prices of the different birthday cards. If you ever bought a card for your mom or dad or whatever, you buy the really cheap ones, or you buy the ones that like make noise and sing to you or whatever. You buy funny ones, or yeah, I always get the funny ones. All right. If I wanted to make a histogram of the prices of all of these um, gift cards, these birthday cards, I would first need to count up how many fall within a particular interval. Scan through the cards right there. What's the lowest price card that you see? There's 17 cents is the cheapest one, right? And the most expensive one, can you see? 385. Yeah. So, what do you think would be a good interval for me to make my histogram here? A quarter, a dollar, 50 cents, 10 cents. Okay. Literally all of those numbers would be good. I can make a interval for the histogram. I'm going to go with 50 cents. And so this is what I would do. I would make a histogram, or I'd make a table, and I would count up how many fall in within each interval. Okay. At a certain point, notice how the first interval says 0 to 49 cents. So only the ones that from 0 to 49 cents do I count up and put in there. I'm not going to go back because I've already done it for you. Okay. Anything that's above 49 cents, so 50 to 99 cents, I count up how many there are, and I keep doing that and so on until I get a total of 30. There were 30 cards in that. All right. And then I would take a blank graph. But this is where you got to be really, really careful. Okay. I put a title and I label both axes, I should say. I start at 0. I start at 0, and notice how I went in intervals for $1, but I really went in intervals of 50 cents because this right here is 50 cents. This is $1.50 right here. This is $2.50 right here, and so on. Okay, $3.50. And then I also want to label the left side. The y-axis on a histogram is always the frequency, or always how many times it shows up. There was one card between 0 and 50 cents. Notice how one thing that I point out is that this interval right here is exactly 50 cents. Even though that this only goes up to 49 cents, it's understood that no matter what this line is, it's always going to go into the next bin, the next interval, okay? So if I have a card that's exactly 50 cents, it's not going to go in the first one. It's going to go in the second one. Does that make sense? If I have a card that's exactly $1, it's going to go in the third bar, not the second bar, not the always the bar after that number. All right. How many cards were between 50 cents and $1? There were 5 of them. So this next bar is going to go all the way up to 5, and I fill it in. How many for the next one? 10. So this bar right here will go all the way up to 10, and I fill it in. See how that works? And then I would keep doing that. I look over here at the bar. There was 5 for the next $1.50 to $2 or $1.99, and I fill it in. 4, and then 1, 3 here, and then 1. And this is a histogram. You don't have to worry about making it by hand, because I'm going to show you guys in your assignment how to do it by computer. But we do need to make sure to know how to read them. Okay. So let me ask you a question just by looking at this histogram. How many birthday cards were between $1 and $2? How many? It is 15. Okay. And a real easy way that people do to add some of these questions up. Hey, there's 10 here. There's 5 here. I add those together, 10 and 15. A lot of times you'll see histograms where they actually just write the number at the top. So it's real easy to see how many there are in each bin. And when I say bin, the bin is that width. Okay? Each one of these bars is called a bin. Easy or hard? Pretty easy, right? All right. So on Friday, we talked about the CUS method describing the center, so mean, median, or mode, any unusual features, gaps or outliers, and then the shape of the graph, whether it's symmetrical, skewed left, or skewed right. Okay. The last one that we didn't talk about was talking about the measures of spread, and this is the only other part that I have in this first one. You guys know what the range of numbers is, right? In this class, who can remember from a few minutes ago? What was the range of grades for the test in this particular class period? What was the highest score? 91. What was the lowest score? A 4. So the highest score was a 91. The lowest score was a 4. What's the range of grades in this class? Look at the definition on the screen. Say it again. Other way around. Maximum value minus the minimum value. No, what's 91 minus 4? Yeah, he said 91. 87. 87. Okay. So 91 minus 4 would be 87. That's the range of data. Okay, that's a measure of spread. How far is how does it go from the minimum to the maximum? Now that 4 is an outlier. Somebody started the test picked one answer and then never finished it. Okay, that's what happened with somebody in this class. Actually, like 2 people did that. Doesn't really represent kind of everybody in the class. Another measure of spread is called standard deviation. Have you ever heard of this term called standard deviation? No? Okay. This is new to you guys. This is big in statistics, and there's a lot of information in terms of standard deviation. I'm just going to give you the broadest definition possible, okay? Because there's a big formula to calculate it, and I'm not going to teach you how to do it. Calculator is going to do it for you, all right? No point in me teaching you guys how to calculate it. However, you do need to know what it measures. Standard deviation measures how far spread out our data is. Okay. If most of my grades on the test were like right in the 70s, it would have a really low standard deviation because everybody scored right around the same amount. Okay. The average is everybody's really close to the average. But if I had a lot high range of numbers, I had some high numbers, I had some low grades, and not a lot in the middle, then that's got a high standard deviation. The standard deviation is actually measuring the average distance from the mean from each individual data point. And if you have a low standard deviation, every data point is closer to the mean. Okay, so if the average on the test was a 70, then you have a lot of grades in the 60s and a lot of grades in the 70s, okay, right around 70. But if it has a high standard deviation, that means the data points are really spread out. So I can still have an average of a 70, but I have a lot of grades in the 50s and a lot of grades in the 90s. Does that make sense? Still, they're just more spread out. Here's what it kind of looks like on a scale that I created. Look at this test average. The average is an 80. There was 5 tests. There was a 76, a 78, an 80, an 82, and an 84. You think this has a low standard deviation or a high standard deviation? Low, right? The average is an 80. All these grades are within a couple points, right? They're pretty close. It's a low standard deviation. What about this test grades? Same. There's 5 tests. The average is still an 80, but look how they're a little bit more spread out. A 70, a 75, an 80, an 85, and a 90. Is this a lower than the previous one or higher standard deviation? It's higher. They're also a little bit more spread out. The average is still an 80, but they're a little bit more spread out, right? And look at this last one. Average is still an 80. Average is still an 80, but now they're a little bit more spread out. I have a 60, a 70, an 80, a 90, and now a 100. Low or high? That's a high. And you can see I have low, higher, and highest. That's what standard deviation measures. If your data is more spread out, it has a high standard deviation. If it's very close together, it's got a low standard deviation. And that's all you need to know for this class. If you take a statistics class in college, you're going to a little bit more in depth than that. But standard deviation helps out a lot. And you're going to go through an example where you're testing bags of potato chips on your homework and seeing how that actually affects the manufacturer of a bag of potato chips. How many of you buy potato chips and it says X amount and it's like half full of air and you get all pissed off, right? So I have something for you guys to investigate on the computer in a little bit when you go through that. I think I only have one more slide on here. So look at the distributions of A, B, and C. And now we're going to kind of look at it on a histogram for the standard deviation. Each histogram has the same mean and the same range. So they have the same average and they have the same distance from the minimum to the maximum. Same distance for all 3 of them. But does that mean they have the same variability? Variability is another word for how much it's spread out, the standard deviation. Take a look at all 3 of these. They have all the same average. Average is right in the middle. We know that because they're all what? All 3 of these graphs are all shaped like what? They're all histograms. What's the shape of all 3 of these? You forgot shape? Is it skewed or symmetrical? They're all symmetrical, right? If it's symmetrical, the average, the mean and median have to be right in the middle, right? So we know the mean is the same on all these. And if you look at the range is all the same. The lowest to the highest is all the same on all these. Even without numbers, we can tell it's all the same, okay? But which one has the lowest standard deviation? Why does A have the lowest standard deviation?
Because it has more than just a 1, 1. Like, it has 2 lower things than the high.
Well, the mean is on the middle of all of these, right? A has to have the lowest standard deviation because where's most of the data? In the middle, right? Which one has the highest standard deviation? C does, because where's most of the data? Spread out on the ends. Okay, and then the one in the middle has the standard deviation in the middle. Okay, A has the least because it's the most compact. Most of the observations are close to the mean. Most of the data is in the middle, where the mean is at, where the average is at. But the last one has the highest variability, the highest standard deviation, because that's exactly where all the data is on the outside, away from the mean. We know the mean still has to be in the middle because it's symmetrical. Remember, if a graph is symmetrical, the mean and median have to be in the middle. Okay, mean and median have to be in the middle. All right, and that is my super short lesson on histograms. So you guys will have a homework assignment that's already posted for you guys to do, and it shouldn't take you more than about 20 or 30 minutes, and we can start on that after lunch because I'm open up the computer lab. Okay.